Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P2122 indicates an issue with the Accelerator Pedal Position APP sensor A, specifically a low voltage condition in the circuit. This code falls under the Powertrain Control Module Fuel Injection (PGM-FI) codes. The APP sensor plays a vital role in conveying the driver's intentions to the engine control module by monitoring the position of the accelerator pedal. This information is essential for controlling engine power output and ensuring smooth vehicle operation. The sensor is typically mounted on the accelerator assembly itself, making it vital for accurate pedal position reporting. Knowing how to effectively troubleshoot this DTC is crucial for maintaining the performance and safety of the Honda HR-V. The app sensor A, also known as throttle position TP sensor D, is responsible for reporting the position of the accelerator pedal to the powertrain control module PCM or engine control unit ECU. It allows the vehicle to determine how much power to deliver based on how much the driver is pressing the pedal. The sensor is usually mounted on the accelerator assembly, directly linked to the pedal mechanism, ensuring that any movement of the pedal is accurately translated into electrical signals. These signals play a critical role in the vehicle's throttle response and overall performance. If the circuit experiences a low voltage condition, it may disrupt the communication between the sensor and the PCM, leading to potential drivability issues. Recognizing the significance of this component and how it is integrated into the PGM-FI system is key to resolving the DTC P2122. Several factors can lead to the P2122 DTC being triggered. One common cause is poor electrical connections or loose terminals at the APP sensor and PCM. Such issues can lead to intermittent failures or inconsistent readings, making it vital to check for solid connections before delving deeper. Additionally, wiring problems, including shorts or opens in the wires, can significantly affect the sensor's voltage output. Another possibility is a faulty APP sensor itself, which may require replacement if it fails to provide accurate readings. Lastly, an outdated PCM software version can lead to miscommunications within the system, as the software controls how the PCM interprets sensor data. Therefore, each of these possible causes should be thoroughly investigated during the troubleshooting process. Symptoms associated with DTC P2122 can manifest in various forms, primarily affecting the vehicle's performance. A poor throttle response is one of the most noticeable signs, indicating that the vehicle may not accelerate as expected. Drivers may also experience engine stalling, as the PCM struggles to manage power output without accurate information from the APP sensor. The check engine light illuminating on the dashboard serves as a warning indicator that there is an issue that needs attention. In some cases, drivers may find themselves experiencing reduced power output, making it difficult to maintain highway speeds or accelerating efficiently. Identifying these symptoms promptly can help prevent further complications and ensure that necessary repairs are made in a timely manner. The first step in troubleshooting DTC P2122 involves verifying the problem by turning the vehicle to the on mode. Immediately upon doing so, utilize the Honda Diagnostic System, HDS, to check the current voltage conditions of the APP sensor A. The parameter you specifically want to observe is the voltage output. It should measure less than 0.2 volts under current conditions. By verifying this parameter, you can determine whether the issue is consistent or an intermittent one. If the current conditions match the specified threshold, the failure can be considered confirmed, allowing you to proceed to the next troubleshooting step. However, if the signal does not align with the threshold, It may indicate an intermittent failure, prompting the need to check for poor electrical connections or loose terminals, either at the APP sensor or the PCM. In the second step, you should first turn the vehicle to the off or lock mode. Following this, disconnect the APP sensor 6P connector, which will help isolate the sensor from the vehicle's electrical system. Once disconnected, turn the vehicle back to the on mode to facilitate a voltage check. Measure the voltage between test points, which consist of the 4th and 5th pins of the APP sensor 6P connector. An important parameter to check is whether you see about 5.0 volts at these test points. If you do, it indicates that power from the vehicle's electrical system is reaching the sensor, allowing you to proceed to the next step. Conversely, if this voltage is absent, it could suggest a more serious issue affecting the electrical integrity of the system. Step 3 requires the vehicle to be turned off once again. Jumping the SCS, service check switch, line with the HDS is crucial to access necessary diagnostic functions, after which you will disconnect the PCM connector A, 51P, isolating the PCM from the circuit. Continuity needs to be checked between the APP sensor 6P connector pin number 6 and body ground to ensure no shorts are present along the APS1 line. This line connects the APP sensor to the PCM, making it vital to check for a continuous connection. If continuity is confirmed, it indicates a shorted wire in the APS1 circuit, necessitating repairs between the PCM A28 and the APP sensor. If no continuity is found, it suggests the absence of a short, leading to the next troubleshooting step to examine open circuits. In the 4th troubleshooting step, you'll need to connect terminals A and B using a jumper wire to complete the circuit. Terminal A is situated at the APP sensor 6P connector pin number 6, while terminal B connects to body ground. Following this jumper connection, continuity needs to be checked between the specified test points again, particularly from the PCM connector A, 51P, pin number 28 to body ground. If there is continuity at this stage, it means that the APS1 wire connecting the APP sensor and the PCM is intact. On the contrary, if there is no continuity, this indicates an open in the APS1 line, necessitating repairs to resolve the issue. This step is crucial in pinpointing the location of the electrical failure and ensuring reliable signals to the PCM. For the 5th step, first ensure to remove any jumper wires from the APP sensor 6P connector and reconnect the PCM connector A, 51P. This step reinstates normal connectivity of the components. Subsequently, use a jumper wire to connect terminals A and B, where terminal A connects to APP sensor 6P connector pin number 4, and terminal B connects to pin number 6. With the vehicle in the on mode, check the APP sensor A values using the HDS to see if they remain less than 0.2 volts. If they do, one potential resolution could be to update the PCM software, as an outdated version can sometimes lead to miscommunications and faulty readings. Alternatively, if this measure does not rectify the issue, substituting the PCM with a known good one is recommended. Final confirmation that the DTC P2122 has cleared, either after an update or substitution, signals successful troubleshooting. The final troubleshooting step involves key checks for the VCC4 line to ensure stable electrical connections. Begin by turning the vehicle to the off mode, which is crucial for the safety of the electrical system. With the SCS, service check switch, line jumped using the HDS, disconnect the PCM connector A, 51P again. Next, connect terminals A and B with a jumper wire, where terminal A corresponds to APP sensor 6P connector number 4, and terminal B is connected to body ground. You must then verify continuity between the specified test points, particularly from the PCM connector A 51P pin number 38 to body ground. If continuity is confirmed, it indicates that the VCC4 wire is intact, which directs the technician to consider updating the PCM if necessary, or substituting it with a known good module. However, if continuity is absent, this would signal an open in the VCC4 wire, requiring immediate repair to restore functionality. After completing all the necessary troubleshooting and repairs based on the identified issues relating to DTC P2122, it is paramount to perform final checks. Begin by ensuring that all connectors are securely reattached and that any jumper wires have been removed. Clear the DTC from the system using the HDS to erase any diagnostic memories. Following this step, conducting a test drive of the vehicle is vital to verify that the original issue has been resolved. Monitor the performance, particularly the throttle response, and ensure that no warning lights illuminate on the dashboard. If the check engine light remains off and the vehicle operates smoothly, you can confidently conclude that the repairs have been completed successfully. Preventive maintenance is crucial to ensuring that DTC P2122 never reoccurs. Regularly inspecting electrical connectors for corrosion or looseness helps maintain reliable connections throughout the system. Additionally, it is recommended to periodically check the integrity of the wiring that connects the APP sensor to the PCM, which includes inspecting for fraying, shorts, or breaks. Keeping the vehicle's PCM software up to date is essential, as outdated software can lead to misinterpretation of sensor data. Incorporating these preventive measures into routine vehicle maintenance can significantly reduce the likelihood of similar issues arising and enhance the longevity and performance of the Honda HR-V. In summary, understanding the pivotal role of the APP sensor in the vehicle's operation is crucial for effective troubleshooting of DTC P2122. The step-by-step approach outlined ensures that technicians can accurately diagnose and repair issues related to low-voltage circuits. Conducting thorough troubleshooting helps eliminate common causes while identifying potential electrical failures. Moreover, following up with preventive maintenance will help keep the sensor and PCM functioning optimally, avoiding any future complications. By adhering to these practices, Honda HR-V owners can ensure reliable vehicle operation and improved drivability. Please like and subscribe to the channel. See you next time.